Hello, Professor Hook. I come to you quite early in the morning as I've spent a good portion of my day in OKC doing the pitch competition stuff. We ended up getting second place, which is really cool, but you care about the project here, so we can start off, we can just run it real quick. Um, Let this guy load up. We can see our Mav. Now we can see our data. As you can imagine, the red is our estimation. So we can see for most of this data, our estimation is following our actual value pretty well. There's this fun one where we're predicting the future quite um, predictably. We're predicting the future, which is funny. There's a little bit of noisy signal in some of these, which is fine because that's kind of like a part of the bit. Because we're getting sensor data, which has a standard deviation on it. But the sensor data is following where the airplane is actually going and all these metrics between the red and the green lines with our estimated and our actuals. So it's working. We can jump into the we can jump into the changes so far. So the standard stuff like changing the path and pulling the right autopilots and what have you at the beginning of the launch file. We also pass some stuff over into Observer that we're going to be using. So that would be Mav sensors as well as some other stuff down here like Mav true state we're passing in. Yeah, we can jump into Observer real quick. So Observer starts at the update function in the Observer class. Notably, at the beginning, after getting some values, we can use the alpha filter, which just functions as a low pass filter for some of this data. That this data is going to end up populating the estimated state data that we'll be using later. Some fun absolute pressure stuff. Really, the meat of the project is these two functions right here. Attitude and position. So attitude is going to be related to your phi and your theta, and position is going to be related to your position, velocity, and orientation, um, which we can jump into real quick. So attitude, you'll enter down here, and you'll start at the update function, which immediately calls propagate model. Propagate model is just this iterative process where you're trying to predict where these future sensor values. So particularly with the help of this f function, which will derive phi dot and theta dot, and those are the rates of change of those, and those will be utilized to try to predict the future value of those variables. Once we have a reasonable estimation of the future value, we can go to measurement update. Notably in measurement update, what we're doing is we're comparing our real value versus our predicted value and seeing if it's within tolerance, which is this guy right here, within threshold. So if it's an acceptable value, like it's not terribly unreasonable for the estimation to be a certain value, then we can accept it and push it. Yeah, and the same thing goes on in the position EKF function, where you enter through the general update. And we'll go to propagate model. Propagate model is again iterative in this process, and we're trying to check future values. But there's just a lot more going on here with GPS and there's a lot of extra variables in this one compared to the first one. So wait, I'm a little lost. Sorry, one moment. Yeah, so F here. So there's this wall of equations which now is a good time to say that like there's a lot of equations in this project that I've pulled that I just don't fully understand, but I don't think that's terribly unreasonable that I can treat some of these things like a black box. Um, just because this is a quite a complicated project. I know this one came from here, um, which is just it's just typing in equations. It's not something super pivotal for the predictive model here. Um, and this is a reoccurring theme of just copying equations. Oh, and there's a few other. Oh, well, not my ChatGPT window. You don't need to be seeing all that. Um, yeah. So there's some fun stuff in the book where I had the original book and I didn't know that this was a thing in the updated book, which has ended up coming in handy for some parts of the project. Um, where it'll just kind of like spoon feed you some of this code, which is pretty nice. Um, yeah, so having the updated book for this particular project was necessary. And again, there's a lot of lines of code in here that are sprinkled in to the project as a whole. Um, yeah, me referencing where I'm poking at stuff. Um, what do I need to be talking about?